So today on the bench, and actually if you watch the other video, I'll probably upload both videos the same day. So, and probably the first video is going to be the one where I troubleshot a problem this radio had, which was a bad relay. Only other things I've done to this radio since then was replaced one burned out meter light and replaced that LED that was also burned out. Now, for starters, the dial is out of calibration on this. I'm not going to cover that in this video. What this video is going to cover is something that you can do, and it doesn't necessarily have to be a Browning Mark IV, or it doesn't have to be a Browning. It can be pretty much any radio, any old tube type radio. The requirement for this procedure to work is it must have a spot switch. Now, pretty much anything that had separate transmit and receive dials or controls is going to have a spot switch. So even if it's an old 23 channel tube rig, you're not going to find this on solid state, but on your old tube rigs, it wasn't uncommon for even the one box. So it doesn't necessarily also have to have a separate receiver and a transmitter. It can all be in one box. Lots of companies made radios like that as well. So this one has a PLL synthesizer circuit, a solid state synthesizer circuit for the transmit frequency. And it's not adjustable from the outside of the radio. That's only, by people like me. When you're doing an alignment to it, it's adjustable from the inside. But the receivers are tunable, okay? So they actually have a VFO. This is not like a normal radio where you turn a channel selector and both of your transmit and receive channels are the same. These old radios weren't like that. They had a separate transmitter and a separate receiver. Shared a power, in the case of this radio, it basically shares a power supply and the relay, and that's about it. Really not much else that's shared. Everything for the receiver is done independently, just like the transmitter. I mean, the receiver you can make work without the transmitter. You just have to jumper some wires where the interconnect plug goes, over to the transmitter. But yeah, and basically what you're doing is jumpering relay contacts where normally it would be some of the circuits would be completed from the relay. But in any case, what I want to cover is if your radio's deaf. Basically the easiest way to put it. You got a radio, it used to receive great, and now it's just not so good. People that used to hit you really strong, they're starting to fade, and the mud ducks, well, they're just not there anymore at all. There's something you can do to a radio if it has the spot switch. Again, that is a requirement. Must have that spot switch. But if you have a spot switch in your old tube radio, you can adjust for sensitivity yourself. The only thing you need is an alignment tool. And a screwdriver. You got to get your top cover off. In the case of this radio, you just need to take the top cover off. But yeah, just an alignment tool. Now, what we're going to do is, now this is not a full alignment. Let me make that clear up front. We're not adjusting any oscillator circuits. I'm not even going to cover calibrating the dial on this radio. This is just the sensitivity of the IF transformers. But it's something, like I say, that you can do very simply. And in a lot of cases, if your receiver has started to lose sensitivity over the years and over the decades, this, a lot of times, can bring a lot of that lost sensitivity back. May not fix all your problems. Very likely you could have other problems. Other circuits where you actually need test equipment, to do an alignment. But this portion of the alignment, you don't need anything but this. There is one piece of test equipment needed, a signal generator, but luckily, that's what the spot switch is. We're going to use our transmitter as our signal generator, because that's exactly what the spot switch does. When you push the spot switch, it generates a carrier in the transmitter. Some of that leaches over in here into the transmit or into the receiver, and we get a needle deflection on the S meter. So now in this radio, the actual procedure for doing an alignment and the parts we're going to be adjusting for the cans in this specific model, make and model of radio, the Browning Mark IV, and it's going to vary from radio to radio, manufacturer to manufacturer. But in this radio, we're going to be adjusting these 5 cans right here. Okay, they're double-tuned cans. Get into that in a second. Now, if you're not working on a Browning Mark IV, like I say, this procedure will pretty much work for any of the older radios. You would need to get a service manual. In most cases, not all, but most cases, you can get those manuals online for free. And a good repository of that is cbtricks.com. So just go there or somewhere where you can find a service manual. What you want to look for is the alignment procedure. In that alignment procedure will be a section called the receiver alignment. That's specifically what you're looking for. One of the steps in that receiver alignment is going to tell you to adjust a bunch of IF transformers. It's not going to be just one. It's going to be several of them. And that, again, can vary from radio to radio. This one has five tunable transformers with 2 adjustments per transformer. But you're looking for one where it's going to be telling you to inject a signal into the radio, and then you're going to be adjusting, in most cases, actually not this radio, but in most cases, in a lot of radios, it'll tell you to adjust for maximum sensitivity. And usually what they'll tell you to check for sensitivity is a meter. Is what you do is you just hook a voltmeter, an analog voltmeter, an audio voltmeter up to the speaker. And you're just adjusting for maximum voltage at the speaker output, basically. This radio is different. They tell you to inject a 455 kilohertz signal directly at the 455 circuit down here, and then you're adjusting for a maximum DC voltage. But this procedure, it basically accomplishes the same thing. You're generating a 27 megahertz in the, depending on your channel you're on, but in the 27 megahertz range, you're generating that frequency here. It will get knocked down to that 455 kilohertz signal, and that's what's going to give us needle deflection. So you push the button here, you can see the needle moves. Okay, and that's what we're going to use as our meter, is the S meter. So we don't even need a speaker or a voltmeter attached to the speaker. Everything we need is right here. This is all we need, and this procedure works just fine. I have done these radios using the book procedure. So hook up a signal generator like that, or the one up there, or any of my other signal generators, injected a 455 kilohertz signal at the designated point, and take a DC voltage measurement, basically at the output of the circuit, and then come back through and do the exact same alignment using just a normal signal generator through the antenna input. It's exactly the same, and then do it with the spot switch, get the same results. In all cases, you end up with the same thing, a 455 signal coming into this circuit, and you're peaking this circuit for that 455 kilohertz. So, what the hell do I do, Mike? Well, the procedure is real simple. You want to, now it's going to vary if you have a 23 or a 40 channel radio. If you have a 40 channel, you want to do this alignment at the center of the frequency range of your radio. So on a 40 channel radio, you want to pick either channel 19 or channel 20. If you have an older 23 channel radio, you want to pick like channel 11. You want to pick something in the center of the band. The reason for that is if you do this alignment, let's say you were to set this transmitter on channel 1, and you do your alignment on channel 1, there's a high probability that then your receiver, by the time you get to channel 40, receiver sensitivity is going to start to drop off. So we want to peak this circuit in the center of the frequency range that the radio works on, so it drops off evenly, maybe towards the outside edge. We don't want to peak it at one end, and then by the time it gets down here to the other channel, it's dropped a noticeable amount. If you peak it at the center frequency, the amount of drop-off you'll have, especially only over 40 channels, the amount of frequency drop-off you'll have over just 20 channels in either direction really isn't going to be noticeable. So that's why you always want to pick the center frequency. So on this specific make and model of radio, what you want to do is set your transmitter to channel 19 or 20. Doesn't really matter. One channel, one way or the other, isn't going to make even probably a measurable amount of difference. But set your transmitter to channel 19 or 20. And what you want to do is, now I know you can't see this dial, and actually you can see how high the needle goes there. If I just turn this off really quick, yes, the dial is way out of calibration. The transmitter was on channel 19. You can see we're almost splitting the number 18. So yeah, I've got some other things I need to calibrate once I get this done. And I just wanted to do this while the customer's got the radio here. Just quickly go over it, get that aligned for them. Just make sure that the receiver is peaked. Actually, what I'll do is I'm going to detune this. I will just pick a couple cans here, a couple random slugs, give them a twist, and we'll just knock this thing horribly out of alignment. Okay, so there. It's been screwdrivered. So this is just like you just got a radio that's been to the golden screwdriver, or a radio that's been sitting around there, been used for 30 or 40 years, and it's just horribly out of alignment, and it's deaf. So that's exactly what this is going to simulate, because I just knocked it way out of alignment. Matter of fact, now it's back on. Let me put the transmitter, get it reset. Put it back on channel 19, and I had not touched the receiver dial here, and I'll hit the spot switch again. Yeah, and you can see the needles straight up and down, and it was way over here before. So yes, we've knocked it out of alignment. So set your transmitter to channel 19 or 20, push the spot switch. What you want to do is grab your VFO, because this, like I say, this has a variable air capacitor for tuning in the receiver. So what we want to do is just push the spot switch, tune for maximum deflection on the needle here. Okay? That's where analog meters are great. You can just get it rock back and forth and then find that peak. Okay? Now, you're going to take your plastic tool, and I cannot overstate this enough. It has to be a plastic nylon Delrin tool. You can go on eBay and get cheap little kits made in China. You can get good high quality ones like a lot of the ones that I have made by GC Electronics. They're Delrin. Doesn't need to be fancy. It just needs to be a proper plastic alignment tool. I guarantee you, I would bet my life on it. Well, there's no bet because I know it's going to happen. If you use a metal tool, you're going to make things worse than they already are. So, what we're adjusting here, inside of here is basically a cardboard tube. Now these are what they call double tune. So there's actually two coils. There's a coil, big wraps of wire around the top of the little cardboard tube on the inside here at the top. And then there's another down here at the bottom. There would be another big huge blob of wire, coils of wire wrapped around there. And it makes up two tunable transformers or inductors. And then there's a ferrite core. Actually, let me just pull one out. I'll just show you what it is. I think they come out of these cans. Yes, they can come out the top. Some of these cans, they won't actually make it past the aluminum. So that's all that's in there, okay? Now, in the case of this radio, this make and model, they have a hex, okay? So they're hollow. So that's why we don't, even on this radio, we do not need to take the bottom cover off. We can stick our tool in, go straight through the top core, okay? I can't turn it right there easily, because that means, without turning the core. If I continue down through, boink, it pops through and I can turn it. And if I continue to go down a little bit farther, I get to a point where it's now in the bottom core is engaged. But the reason we can't use a metal tool is, for starters, if you use metal, you stand a really good chance of breaking this thing. The walls are actually very thin at the points of these edges, and trust me, if you get a metal tool down in there, there's a chance you could crack this thing. That's the nice thing about using plastic tools is, if worst case scenario, the core binds, the tool, you'll strip the tool. Usually just, crap, and you'll look at the end of your little tool and it'll just be round now. It won't be a hex anymore. You can also find these, the cans may look the same as this, but the cores will not be hollow. They'll have a screwdriver slot. They're solid with a screwdriver slot. Now, in the case of radios like that, you will have to take off the bottom cover of your radio because you can't get the tool to go down through it. Now, be very aware. Don't get distracted while you're doing this. I don't want anybody to get shocked, much less die, trying to get some receiver sensitivity back in their radio. Remember, this is a tube-type radio. It has extremely high voltages in it. If you don't know what you're doing, you can kill yourself in these things. So don't go sticking your fingers down in here unless you know what you're doing and where you should be probing and prodding. Don't go, I wonder if there's anything there, and go zap and you're dead. I don't want to hear somebody died because they had their fingers inside your tube-type radio. And the bottom side of this radio is even more dangerous. Everything is exposed down there, and you're guaranteed filter caps. There's lots of high voltage on the underside of this thing. So just be aware of that. Use a plastic tool, and don't go sticking your fingers in there or probing around at parts when it's plugged in. And even when it's been turned off and unplugged, there can still be residual voltages stored in these capacitors. Depending on your radio, they may not have bleeder resistors on these capacitors. So they could potentially hold a charge for weeks or months, You can come back a month later and still get electrocuted. Just be aware of that. I don't want to scare you away. It's just something to be aware of. You're dealing with high voltages. Don't go touching stuff. But like I say, you don't have to. That's kind of the whole point. You're just using this tool. So let me get this little core put back in here. And we'll do the alignment. Okay, so now that we know what tool to use and what not to touch, what we don't want to touch is anything except for the alignments, these cores. And like I say, vary from radio to radio. Just go in and look for the section where it tells you to inject a signal, and it'll give you a line. Like in the case of this one, I think it's, shoot. Let me just grab the manual, and I can actually show you in the service manual for this one. Let's see, receiver. There we go, receiver alignment. It's actually the first section, the 455 kilohertz section, and you can see it's we're going to inject a modulated 455 kilohertz signal to the junction here. Like I said, we're avoiding having to do all that because we end up with the same result. The signal ends up being 455 kilohertz by the time it gets to this portion of the circuit. But in this radio, we're going to be adjusting T, so that's actually the numbers of these transformers down here. It's T201, 2, 3, 4, and 5. And like I said, and you can see it says top and bottom cores. Now, like I say, that's going to vary from radio to radio, so you'll need to look at the service manual. But that's the section you want to look for, where there are multiple cores that it's telling you to adjust for maximum sensitivity. So we've got our transmitter on. We've peaked it. Let's just double check it, make sure I didn't bump the knob. We've adjusted for maximum. Now all we need to do is come over here, try and get all this in the camera here, and you're going to push in your spot switch, and then you're just going to take your tool. Now, it doesn't matter if you do the top or the bottom first. Some radios, they may tell you to do a top or a bottom. That's where you need to read the service manual. But in the case of this radio, it doesn't matter if you do the top or the bottom first. The radio doesn't care. So push your spot switch, and you're going to adjust accordingly. Now, you can see when I turn that core, the needle, it goes down. I turn it in one direction, it peaks, and if I continue to turn, it goes back down. And that's what we're looking for, is that peak. Let me get the camera down a little bit farther so you can see the numbers here. So we just want to peak that. And that's the nice thing about analog meters. It's something it's not impossible, but it's really hard to do with a digital meter, is peak tuned circuits like this. It's really hard to align tuned circuits with a digital meter. Analog meters are nice. You can see that needle swing up, it reaches a peak and starts to drop back off. You can just rock back and forth until you find that peak and stop. So, come up to the top one. Go to the next can. Just continue across through all 5 of the cans. Now, if your radio's way out of alignment, honestly, it's not a bad idea once you get done doing this alignment to run back through all of them again. Some circuits, the way they're set up, adjusting one coil, and that varies from radio to radio. It's more of a circuit design variation between radios. But some radios, like in this one, may have, if you can't see it, may have a transformer that just feeds into another transformer. Where from here, we go from a transformer to a tube. Actually, it's just convenient layout-wise, visually, in these radios. But, the signal basically comes in, goes through 2 transformers to a tube, to another transformer, to a tube, to another transformer, to a tube, to another transformer. And, it's in row. But, like in the case of this one, adjusting one transformer may affect the alignment of the other transformer, and vice versa. You adjust this transformer, it's going to affect this one because they're connected to each other. They're not separated by a vacuum tube. So it's never a bad idea, once you get done going through this one time, just go through it again really quick. Now what I'll do is just to show that it really doesn't make any difference whether we use the built-in spot switch or communications test set. So we'll use a really high-dollar piece of test equipment that nobody, no normal sane radio owner will have. I'll hook that up over here. Okay, we can now actually hear, we can see we actually have a signal. We can hear a signal there, so I want to inject a little bit more. So I'm going to go over here to the communications test set and change that. Okay, so, see we have a good needle to... come on, camera mount. Get all swingy on me now. I turn the volume down. And I'll just go through them again. Okay, now you see it picked up there a little bit. Like I say, those two front transformers, that's why I wanted to run through this one again, because adjusting one can affect the other one. And quite honestly, not going to hurt it if you do it a third time. Now trust me, you get to a point where the juice ain't worth the squeezing. But you can see, basically, other than those front two transformers, like I say, because they're pretty much almost directly coupled to each other, adjusting one can affect the other one. But all these other ones, you can see, I'm really not gaining anything. Where we peaked at using the spot switch is still the maximum. So okay, so that's pretty much all there is to it. Just go through, plastic tool, don't touch anything. All the test equipment you need for doing it using this procedure is built into your transmitter, or if you have one of the one-box radios where your transmit and receive dials or knobs are both in the same unit. But as long as it has a spot switch, you can peak your 455 circuit, your IF or intermediate frequency section with nothing other than that. That's all you need. And you can pick these up on eBay. You can get little kits. You can buy individual ones, but honestly, if you're going to get them, get the kit. That way, if you buy a different radio someday that has different cores, because the hex ends they come in different sizes. There's different screwdriver slot sizes. There's rectangles. There's all different types of ends. So if you get the little kit, some of them even come in a little pocket protector, for the nerdy type people. You can walk around with it in your shirt pocket. But, yeah, handy little kits, and they only cost a few bucks. And that's all you really need to do. And you've now, done an alignment. Now, like I say, the only thing you've adjusted here is the 455 IF section. So if there are problems elsewhere in the radio and you're not a tech, yeah, it's probably going to need to go to a tech to get done, because all of the other sections of this, in this radio, you actually do need test equipment. You can't just use the spot switch or even a signal generator. You're going to need other test equipment, a frequency counter and voltmeters, and you're going to be dealing with high voltages because you're going to be taking measurements on the underside. But this is where you lose a lot of sensitivity a lot of times. There's a lot of components other than just these transformers and tubes. There's a lot of resistors and other components in here that can change value over the years or decades in the case of an old radio like this. And as they change value, they're affecting how this receiver circuit, this portion of the receiver circuit, is tuned. And just a simple, quick screwdriver, and I hate to use that term, but we're not golden screwdrivering it. That's the key. We're screwdrivering it the way it's supposed to be screwdrivered. Well, maybe not screwdrivering, we're alignment tooling it. But, yeah, so I hope that helps. If you own one of these, or basically, like I say, any tube radio that has separate transmitter and receiver controls and has the spot switch, you can peak your 455 IF section there. You may be able to gain back from a little bit to a lot. Because I have seen some radios over the years where that was it. I mean, yes, maybe you pick up a little bit more doing the alignment of the rest of the circuitry, but most of the time, a lot of your loss of signal is in this circuit because it is such a large circuit. There's so many components. So I hope that helps, and enjoy.